There we go. Yeah, thanks everyone. Welcome to today's roundtable on using Git and GitHub in a team. We are recording this and it'll be sometime tomorrow, but we're going to post this on YouTube and we'll post the URL for this video in our Pound Announcements channel. So again, it's pretty important. This is a pretty important topic because in any team where you're developing software, using Git and GitHub is really a requirement these days. There are other source code control systems out there, but I think it's pretty safe to say that Git and GitHub are the most popular. So, and the reason that we need a source code control system like a Git is obviously you're working with other teammates and you're sharing the responsibility for maintaining the same code files, the same code base. So it's really important to oh, would you mute your mic, please? We're getting feedback. Thank you. Yeah, so it's really important to be able to manage the code in a way that doesn't damage it. So, and that's one area where Git really stands out. Git is truly a distributed source code management system. So it can do things like allowing Andres and I to work on the same file really at the same time, but on different computers. And we'll talk about that later on in this presentation, what that really means. All right, so today's agenda, we're going to go through the basic Git commands, and more importantly, there is a workflow behind Git. So we're going to dive into that. We're going to talk about when you use forking versus when you use cloning, and what you need to use in a Chingu voyage, what we recommend. And then we're going to spend the most of the time talking about how do you actually coordinate what you're doing as a developer on the team with other developers on your team. How do you use Git to manage the code? And then finally, we're going to create a PR, what's called a pull request, and we're going to create a merge conflict as well. The dreaded merge conflict, and show you that they're really not as scary as you might think. All right, so the basic Git commands, these 8 commands are actually the ones that I use day in and day out. I do use other Git commands from time to time, but these are the main ones that I use. Now, one of the things that you'll find is that, if you talk to me, you'll see I use these commands and I use certain options on these commands. But if you talk to Andres or David or, Luiso, you'll find that they may use a different set of Git commands, or they may use the same commands I use, but with different options. And it's really important to understand that there are multiple ways of doing the same thing in Git. And that could be a little confusing, but at the same time, what it does is it allows you to tailor your own personal workflow or your own personal use of Git to help you be the most productive developer you can be. So what I do may be different than Andres, but it's what I've found that helps me be more productive. And of course, his way, he has a similar thing where his way is what he's developed and is what he feels comfortable and productive doing. So let's dive in. Let's actually look at a few of these commands and a few Git concepts right away. So I'm going to pull up a Visual Studio Code session. And this is a user Chingu gem. And you can see it's a blank code space. So I'm actually going to go back now to the browser. We're going to go into GitHub, and we have a repo called Roundtable Git Demo. We've been using this for 4 years in this particular presentation. We actually give this presentation about every other month. Um, so the first thing is, let's talk about Git versus GitHub. So Git it's basically a utility that you use on your local PC to manage the code. And whereas Git is a service, it's a shared service. So you're using Git on your local PC to complete your tasks for your team. But when you need to share your code, that's where GitHub comes in. You share your code with the rest of your team through a service like GitHub. So the first thing we want to do is let's make a copy of this repo, this repository, code repository, down on my local PC. So the first thing I'm going to do is I'm going to go to this code button, and I'm just going to copy this URL. And now I'm going to go to my local PC, my Visual Studio Code session. And to bring this down, actually, I need to start a different terminal session. Oh, actually, I guess I didn't. So the git command to clone that repo from GitHub down to my local PC is git clone. And I just pasted in that URL that I copied, and I'll hit enter. And watch this section. It actually flashed by pretty quick. This was an empty directory. Well, now it has a directory, a subdirectory in it called Roundtable Git Demo. And you can see that the output of this git clone command is that, it gave us a summary of what did it do. So we can see that it pulled some objects down from GitHub. It was successful. It's basically just telling us everything worked fine. It did clone that repo. So I'm going to look. We're going to talk about staging files before committing them. We're going to get into that in just a few more minutes. So now I've got this repo down on my local PC. So I'm going to open up a new terminal session. I'm going to actually open Roundtable Git Demo in its own terminal session. And this takes us to our next Git command, which is probably the most frequently executed Git command ever, which is git status. So what git status tells us is basically, what's the status of our local repo? In other words, this copy of the code repository that we've brought down to our local PC. Now you can see that it's telling us that we're on the development branch and that we're up to date with origin development. Now, origin development, that is the version of the repo, and it's the copy of the development branch in this repo that lives up in GitHub. When we did a git clone, it created an alias called origin that is essentially that URL to our code repository in our repo up in GitHub. So now if I want to display, what branches are there on this PC or on this repository, I can do a git branch. And we can see development is the only branch that's on my local PC. And we know it's the current branch because it's got this asterisk next to it. Now, I've customized my terminal session. So, I'm displaying the repo name and the command prompt and the git branch name and the node version number. This will be different on your PC. So just don't be surprised when you do this if it looks a little bit different. So while we're talking about branches, how do you create a branch? So it's actually through this git branch command, but rather than just git branch, we have to give it the name of the branch we wish to create. So I'm going to create one called git branch refactor um, update comments. And now if I do my git branch command again, I can see we have two branches now. We have development, and then we have refactor update comments. So the next thing I want to do is I want to check out this refactor update comments. I want to make it the branch that I'm working in. So let's do a git checkout refactor update comments. And then we'll do a git branch again. And we can see that the current branch is now refactor update comments. Now, one of the things that be aware, if you're concerned about, oh, I don't understand Git, or Git is new to me, don't worry. Nothing brings out the imposter syndrome in, regardless of whether you're a developer, a UI UX designer, a product owner, or Scrum Master, nothing brings it out more than Git. And you'll just have to kind of trust me on this. But as you work more with Git, you'll become more comfortable, and you'll find that these concepts become clearer, and it becomes easier to use. It's like anything else; it takes time. What is that old statement that the definition of mastery is doing something 10,000 times? Well, it's kind of true with any of the tools that we use in software development. All right, so that's kind of a quick overview of some basic uh, Git commands. But let's dive just a little bit further. We've brought this branch, this source code down, and this is just a simple temperature converter. We've brought this down to our local PC. Now let's make some changes. Let's see how we use and interact with Git as we make changes. So because we created refactor update comments when the current branch was development, refactor update comments is actually an exact copy of development at that point in time. So let's make a change. Let's change one of these comments. Let's just say we want to change this.
Like fix the spelling of Celsius?
Let's see, is it misspelled?
Yeah, it's 2 S's, not 2 C's.
Oh, I see. Gotcha. All right, let's do that. I'm a math major.
Degree in chemistry, so yeah.
This will actually be good because this is going to show quite a few changes. I should have just done a mass change, but all right. So we can
It's
see
also
that,
in variable names.
well, then let's do a mass change. Let's do. Yeah, I'm going to let it go for now. I'll go back through this later and change that. So anyway, we've made quite a few changes, and we can see if you're not familiar with Visual Studio Code, it gives us this white dot. That's just a visual indicator that the file is not saved yet. So I'm going to do a save. And then now let's do a git status again. All right, so git status is telling us something a little bit different than what it did before when we initially executed it. What it's telling us is essentially index.js, this particular file has been modified. And in fact, if I changed another file like the README, uh, let's do git status again. Now we can see there are two files that are changed. Now I'm going to go back to the slide deck to show you. Now we're going to talk about the workflow that sits underneath Git. So we've got two files that are modified here. There are actually four different kind of areas you can think of in Git. Now, one of them is your remote repository, which is GitHub. But right now, we've modified that index.js and the readme.md file. Those sit in the working directory. The working directory is just that. It's just an operating system directory that contains the files. So everything over here is the working directory. It's actually not the repo. To see the repo, if I'd have to do a ls -al, this is a Unix command, and we can see this .git directory. So the .git directory is a hidden directory, and that's actually where the repository lives. Let's look at it. So you can see it has other directories and files in it. One of the best practices, you never, ever, ever want to modify the contents of any of these files in the .git directory other than using a git command. And the reason is there are a lot of pointers and relationships that exist between the contents of one of these files and another one of these files. So if you modify the file directly, like through a text editor, you run the risk of basically corrupting your repository. Now, again, this is just the local repository. So our changes are now sitting in this working directory. Now we have to get them in the staging directory. So the staging directory is really just an intermediate area that sits between the actual repo and the working directory. And the way that we add files to it, modified files, is we do a git add. So let's just do that. Let's do a git. Let me do a git status again. I could do a git add and then readme.md and then a git status. And you can see that added the readme.md to the staging area. And one of the nice things about Git is you can see it's giving us a little hint. It's telling us that it's staged, but it's telling us, hey, if we wanted to unstage this, if we wanted to take it out of that staging area and put it back in just the working directory, we would use this git restore command. Now, a command that I use almost 100% of the time, it's a shorthand, it's git add period. What that does is if I've modified 20 files, it adds all of them from the working directory into the staging area. So now if we do a git status, both of these files are staged. So they're still not committed, though. They're not in the repo. And that's where the next command comes in, the git commit. That takes the changes that are staged in the staging area and actually commits them. It actually adds them to your local repository. So let's do that. And then we'll talk about, well, why is there a staging area? So we'll do git commit. And I'm going to give this, I'm going to do this in two parts. I'm going to git commit with two messages. This -m stands for message. So it's the first one I'm going to do refactor update comments, which is just kind of a title at this point, and then a second message, which is going to be more granular. It's going to have a little more detail. So I'm going to say update comments to correct cool. So now that commit worked, and I know that it worked if I do a git status again. And we can see that our working area, our working directory, or working tree is clean. I can also verify this locally by doing a git log. So this head, that basically is the most current commit. So that's the commit that we just issued. It's 5:23 p.m. here, so it's got a date and time stamp. And you can see these two messages that I added to that commit. The first one is a title, and then the second one is something that's a little more detailed. And you can also see I used backticks, and it basically terminated the message at that point. All right, any questions so far? Now, one of the things we didn't talk about is why is there a staging area? Well, the reason is that in some very large projects, you might be doing a number of changes over a period of days or even weeks. So as you're doing changes, this gives you the ability to stage those changes, but to commit them as a single unit. Now, personally, I don't like that mode of operation. I prefer to use what are called atomic commits, which is what Andres referred to in the chat. And one of the reasons I liked, or the primary reason I like to do that, is because I like to make a code change, unit test it, and then commit it. And then that way, if in a subsequent commit, there's a problem of some kind, then I've got what's called a delta. I know when it last worked, which would be the prior commit, so I can look at the differences between the prior commit and the current commit to isolate, okay, what's going wrong? So it's a way to troubleshoot. So I'm going to pause. I see a bunch of folks are typing here, and this flow, by the way, on the top, these git commands show how you move changes from one area of your local repo to the next, and then ultimately to GitHub. And then these ones on the bottom show how to basically pull them from one area back down to the other. Yeah, having an atomic commit, yeah, it's really it's this kind of the scientific method. You're looking at the differences. So I guess you could say in a way that doing atomic commits is the calculus of Git. Yeah, and Andres is going to be doing a roundtable on advanced Git techniques on I think it's the 2nd and the 5th of April. You can find the schedule in the events channel at the top of our Discord server. So anyway, stay tuned for that. You'll find that a pretty useful presentation. Let's see. Seems like staging would be useful if you've got several interdependent files. You decide it's important to change that. Yeah, that's true too. That is true. And again, where I've seen this used is over time, where there's a lot of different changes. There are dependencies between the changes, and the author wants to commit them as a unit, even though it may take several days or again even weeks to to make all those changes. All right, any questions? Otherwise, we'll just charge ahead. Yeah, that's a good point too, Andres. I actually hadn't thought about that before. Using the staging area as a place to review before you do the commit. All right, I may have confused you earlier. I do that quite frequently, as Andres will tell you. Let's do a get branch again. You notice I named this one branch refactor slash update comments. Well, this is a convention that I use. You don't have to use this. You and your team can use whatever branch naming convention you wish. But I use this particular convention. I prefix the branch name with what's the intent? Is it a fix? Is it a new feature? Or is it a refactor? A refactor being I'm changing the code, but the end user is not really going to notice anything. Okay. Whereas a feature, that's something that's like an enhancement where the end user is going to know something changed. So, and then the second piece, the actual name of the branch, I try to make that something descriptive. And rather than going through all of these, this last one is, I think, the best example. If I'm adding a new feature that is a profile form in the application, I'll call it feature slash add profile form, and then I'll suffix it with the issue number or like the user story number or task number in my product backlog. So that way I know what's the intent of this branch or the change that's in this branch. I know, add profile form says a little bit about, okay, what is it that I'm actually doing? What's the goal? And then if I need more details, I can go to the product backlog item number 121 and I can pull up the details. Now, this is actually a really minified version of a popular branch naming convention called conventional commits, I think it is. Yeah. So conventional commits goes into a lot of detail. It has many more of those prefixes than what I personally use. And you can read this. This is actually something that a lot of developers follow. And I don't remember when this started. It's been several years though, but it's gained quite a bit of popularity. Okay. So now let's talk about forking versus cloning. Okay. This is something that tends to confuse new Chingus, especially Chingus that are in a voyage. I just showed you how to make a copy of a repo, how to pull that repository down from GitHub to your local PC. And I did that with a clone. Well, you could also use a command call, or you can use a technique called forking. But what's the difference between the two? Well, let's talk about forking first. Let's assume that we are contributing to an open source project, but we don't have update rights on that project's repository. And that's actually extremely common. When you're a contributor to open source, unless you're on the core team, you'll only have read-only rights against that repo. Well, what the fork does, and a forking is actually a functionality provided by GitHub. It's not provided by Git. So the fork, you execute this or you do this from within the GitHub web page. When you fork someone else's repo, it makes an exact copy of that repo, but it places it under your individual user ID, your individual GitHub account. Yes, this will be available. We're going to put the recording out on YouTube tomorrow. Now, once you've got that copy of the original repo in under your user ID in GitHub, now you can clone it down to your PC to actually make your changes and do your unit testing and do all the things that you would do to add an enhancement or fix a bug or to update documentation. Now, the difference is that when you create a pull request, you would push your working branch up to your repo. But when you create a pull request here, the target of that pull request will be the original repo. And when you create that PR, the owner of this repo, they will then review your change, and they will approve it, reject it, or ask questions about it. So the use case here is that you use a fork or you fork a repo when you have no update privileges against the repo that you're wanting to enhance or modify in some way. Now, the opposite of this is cloning. And cloning is what we suggest in our Chingu Voyage, because the repo that we provide to you and your Voyage team, we have granted everyone on your team administrative privileges on that repo. So you've got those update rights. So it's actually quite a bit simpler. And you've probably already done this, many of you. You'll use a git clone to make a copy of that repo on your local PC so you can start doing your work. So any questions? Okay. Yeah, and we're going to talk about the path for how you do a PR review on a cloned repo. We're going to talk about that in a later session. All right. So since we're talking about voyages, I want to point out that you are free to deploy your application. Oh, thanks, Luis. You're free to deploy your application to any internet web host that you choose. Now, we recommend that don't pay for a web host. There are enough free web hosting services out there that you shouldn't have to pay for anything. And in fact, if you look in the handbook and the landing page, if you scroll all the way to the bottom, under technical resources, there's a section called deploying your app. This lists some of the popular web hosts that have free options. And it also shows, depending on how you've architected your application, like if you have a database, you're pretty much going to be restricted to like a Railway, a Render, or a Heroku, one of those. Not every web host supports a database. Pardon me. But there is this special case with Vercel. Vercel's free tier only allows you to deploy from a individual GitHub user account. Now, if you look at any of the repos that we provide for a voyage, they all live in Chingu Voyages, which is known as a GitHub organization. So if you want to use Vercel, you'll basically get a deployment error. It won't let you deploy from repo in Chingu Voyages. So what do? How do you get around that? Well, the workaround is that you would still, you and your team would still develop from a cloned version of the repo we provide, But when you get ready to deploy, have one teammate fork this repo and then deploy it from that teammate's GitHub account out to Vercel. Now, an even better approach, because if you have one person that does this and they suddenly have to work overtime or they're unavailable and your team needs to make a change, then you need to redeploy, you would be stuck. So one of the workarounds for this is to create a shared account. Create like a Gmail email account, register that Gmail account as a GitHub user, open up a new GitHub account, and then share the credentials among the team, the logon credentials. I would never, ever, ever share anyone's personal logon credentials with anyone on the team. I don't share my credentials with my wife, to be real honest. So, sharing credentials is just a really bad security practice. But this is how you get around that. And some of you may be asking, well, since there are other options other than Vercel, why would I deploy to Vercel? Well, Vercel is the major backer of the Next.js library. So if you're a React developer who's using Next.js, you're going to get the best support possible in Vercel. So that's one reason that you would want to deploy there. Now, that's not to say that you couldn't deploy a Next.js application out on Railway, for example, but Vercel, because they really control that project, they have the best implementation. Yeah, Andres. All right. Any questions about this? Okay. All right. Let's get down, I guess, to more details about how do you really use Git in a team. So the first thing we have to talk about is the structure of your branches. So there are essentially two types of branches that will be in your repo. The main branch and the development branch are shared branches. Everyone on the team uses these. The main branch contains all of your production code. When your team is developing the application, when you do a release, your code that you fully tested and you're ready to share with your end users, you're going to PR that up to the main branch. And that main branch, you should deploy it out to the internet to a web host. Underneath that, this is a hierarchy. Underneath that is a development branch. Now, the development branch is a common branch shared by the team, but it's where everyone that's working on changes merges their unit tested changes at the end of the sprint. So if I'm working on a new feature and Alina is working on a new feature and Luis is working on a new feature, we will all three, by the end of the sprint, we will push our working branches up to GitHub and create PRs, pull requests, to merge our changes into the development branch. And we recommend that you also deploy that development branch out to an internet host as well. Now, the reason being is that, my unit tests can work just fine, and Alina's unit tests can work just fine, and Luis's unit tests can work just fine. But when we do all three of our merges, that doesn't mean that our code will necessarily work together the way we expect. So once your team merges your changes into the development branch, you need to do what's called an integration test. So that's where you use this deployment out to the internet that's based on the development branch. That's where you basically test the code to make sure that everybody's changes works together. Now, just a caution, we tend to think about bugs. We tend to think about, oh, well, the integration test will fail if Jim's change generates an error message, uh, you know, after being merged with Alina and Luis's code. But it could be that it's not a bug that we see. It could be something called an unintended side effect. It could be maybe it's some type of like data representation error or calculation error. It's something that doesn't generate an error message, but the output is still wrong. So again, there's one main branch and one development branch in a repo. Now, below them are working branches. So every developer on the team, you're going to have your own set of working branches. And typically, the way this works is you have one working branch for every feature that you are implementing. So at the beginning of the sprint and the sprint planning session, if I volunteer to work on two tasks, I will start out with the first task and I'll create a working branch for it. And then when I'm done with that and it's PR'd, I'll create a working branch for the second feature and I'll start working on it. So that way you have these it's this concept of atomicity, working in atomic units. I've got atomic working branches just as I have atomic commits. Now, when you create your working branch, what you'll do, the flow to take is, or to follow, is to, in your local branch, check out the development branch and pull the development branch from GitHub down to your local PC. And then after you've done that, create your working branch from the development branch. And that way, you've got the latest and greatest set of changes. You've got that copy of the development branch that everyone else has merged into up to that point. So then as the sprint progresses, you'll be working in this branch. You'll be making code changes and unit testing and updating a README potentially. And when you're done, when you're finished your work, your unit tests are all finished, what you should do is pull that development branch one more time. And the reason you do that is that, let's say I created my working branch on a Monday and I'm making all sorts of changes, and then I'm not done until Thursday. But Andres, he finished on Wednesday and he merged his changes into the development branch. Well, that means if I don't re-pull the development branch down into my working branch, I'm not going to have all the changes that the rest of the team has made before me, or at least that they've made since the beginning of the sprint. So what you'll do is you'll pull that development branch down. You'll see if were there any changes that came down. It could be that you would get a merge conflict at this point as well. And that's okay, because merge conflicts are always easier to fix on your local PC. So you'd pull that down. If there's any changes, you redo your unit tests, and then you'll push your working branch up to GitHub, and you'll create a PR to merge your unit tested changes in this working branch into the development branch. So I want to pause and see if there's any questions. That's an awful lot. And in fact, the next slide actually has a lot of the detailed steps. I'm pausing because I see Andres is typing. Okay, the good question. Who or what acts on the PRs? So when you create a PR, this is something that you do in GitHub. It is not a Git concept. What the PR stands for is pull request. And in fact, I'll show it to you here in a minute. I think that'd be easier rather than me describing it. But basically, a pull request is your request to the rest of the team to merge changes into a branch, like the development branch. Um, and with that, there is a review process. You should never review your own code, at least not before a merge. It's always best to have someone else review it because chances are they're going to see things that you didn't. Yeah, so let's do that. Let's create a PR. So I'm going to put this README away. Let's see what's the state of our uh, changes right now. So I'm going to do a git status. Okay, so our working tree is clean. We already did a commit. So what I'm going to do now is I'm going to do a git push origin refactor update comments. Basically, this is going to push that up to GitHub. It's going to push this branch. So before we execute this, let's go up to GitHub and look at the branches. So when you're in this code tab, you'll see this some number of branches. So we've got a lot of branches out here, actually. I'm going to get rid of some of these. I'm just going to delete them. And I'm going to refresh my screen and let's see what it looks like. That's a little cleaner. So refactor update comments. Oh, I haven't pushed yet. I'm sorry. Now let's push this. All right, so it worked. Let's go back to GitHub and we'll refresh this screen and see what it tells us. So now we can see refactor update comments. It was updated just now, and we can see it's one commit ahead of the development branch. So basically what that says is it has one change that's not in the development branch. So let's create a PR. What a PR does is it's what actually merges changes from one branch into another. So we'll go to pull requests, and we can see that GitHub detected that we had a change. So we're going to create that pull request. Because I only have one commit in this PR or in this PR, it copied over my original commit comments from that earlier commit. So this is a little mechanical. I'm going to assign myself as the assignee. I like to give it a label, so it's documentation. If I were doing this for real, I would assign one member of my team to do the review. So like I might assign Andres. And when I do that, this PR can't be merged until he completes a code review of it in GitHub. So this is able to merge. So let's do it. Let's create the pull request. And we can see that, well, first of all, I need to update my comment. Remember, that was that problem with the quotes that in my original commit. So I'm going to say, yeah, so I updated the comment. There's no conflicts with the base branch. What this is a check that GitHub does to make sure that my changes won't overwrite anyone else's changes or vice versa. Everything is correct. Now, before we go on to merging this, if I look at this commit, GitHub is just, I love GitHub. If I click on that commit number, it's going to show me exactly what lines were changed. Now, it'll always show them as a series of deleted and replaced lines, but it highlights the actual words or parts of each line that were changed. So this is a great debugging tool. It's also a great tool that when you are the reviewer of a PR, it shows you here's what the other developer changed. So let's do a review. This is kind of meaningless because this really should be someone else, but this will show you what the review process looks like. What I would do is I would go through this code as a reviewer, and I could add a comment. So it looks really good. You know, I can make all sorts of comments on a line by line basis. And then when I'm ready, once I've finished that, I can leave a final review. Now I could, in my case, I'm doing a comment here. Pardon me. I also have the option, I could approve it or I could request changes. So I'm just going to submit the review. And you can see that GitHub, it annotates that part of the code with my comment. And now I'm going to merge the change. So now that this is merged, it's all complete. If I go back to the development branch and I pull up index.js, I should see these changes. And remember, and I do. Celsius is correctly spelled in at least most of the spots. You can also see we changed the Celsius to Fahrenheit to be C to F. So now the development branch matches that refactor update comments branch. And again, I can verify that if I go to the code tab and I look at the branches, I can see that update comments is now no commits ahead of the development branch. Now, it is one commit behind. So why do you think it's one commit behind? Remember, when we started this, it was 0 commits behind. Well, the answer is that when you do a PR, GitHub adds like a breadcrumb. It adds a commit that documents that the PR was done. So that's why it's now one commit ahead, or why the development branch is one commit ahead of our original branch that we started out with. So any questions or confusions before we go on, or anything at all? What we're going to do next is we're going to create a merge conflict. But I'm going to wait. I see some folks are typing. Let's see. A consequence of merging is it produces a merge commit and adds it at the end. Yeah, that's exactly right. That's exactly right. All right. So let's create a merge conflict now. So we did all of this under this Chingu gem. Let's bring up another Visual Studio Code session called RT gem. And I'll need to make this a little bigger. So let's go back to GitHub. Let's clone, or let's clone this repo. So again, to do that, I'm going to go to the code button and I'm going to copy that URL and I'm going to go back to my RT Chingu gem. Sorry, that's RT Chingu gem. I want RT gem. There we go. So now I'm going to do a git clone. And when I hit enter, keep an eye on this section. You'll see that subdirectory be created by the clone. There we go. So that's created. I'm going to open a new terminal session that's on this subdirectory that's in this repo. And now I'm going to create a new branch. Actually, I'm going to do something else first. I have to create the merge conflict. So this is something I'm going to do that you should never do, and that's modify the file directly in GitHub. So I'm going to change this to be Celsius to F. And I'm going to commit the change. Cool. So that is committed. C to F is now Celsius to F. So now if I go back to my Visual Studio Code session, here we go. So now the situation we have is I have a copy of the development branch that was made before we updated index.js inside GitHub. Again, that is a bad practice. You really only want to make changes on your local PC and go through the PR process. That's the safest way. But now you can see this says C to F instead of Celsius to F. So now I'm going to change this comment to be C to Fahrenheit. And I'll do a git clone or a git status rather. I can see I have one file change, so I'm going to add it from the working directory to the staging area. And I'm going to do a git commit. And we're going to push it. Oh, I didn't create my branch. I have to do that first. Git branch. There we go. So now I've got this change localized in a working branch. And we can see it stayed the same. It's C to Fahrenheit. So now what I want to do is I want to do a git status just to make sure everything looks okay. And it does. So I'm going to push this branch up to GitHub. Okay, it pushed it up. So now let's go to GitHub and let's take a look at this branch. So we can see here's modify comment. It's one commit behind and one commit ahead. That's a kind of another little danger signal that there could be a merge conflict sitting in here. What we would expect normally is it's some number of commits ahead of the target branch, but it's 0 commits behind. So let's create a PR now. Oh, GitHub already knows that it can't automatically merge. We're going to go ahead and create the PR though. Okay, so let's see what it tells us here. So basically, there's a conflict in the index.js file. Now, I could resolve that in GitHub, but again, that's not a best practice. It's really best that you do this on a local PC. And one of the reasons is that after you've resolved the conflict, you really want to rerun all your unit tests. If you just make a change up in GitHub and then you complete the PR, well, you've essentially you are committing untested code. So now to resolve this problem, what do? Well, let's go back to Visual Studio Code, RTGem, and what we're going to do is we're going to pull the development branch down into this one. So we're going to pull our target branch down into our working branch because there's a discrepancy. There's a problem that the two have histories that aren't in sync, change histories. So we'll do a git pull origin development. And now we can see it tells us we've got a merge conflict. And you've probably noticed that it's inserted some additional lines in our source code file, in the file that has the merge conflict. Now, there's no programming language, at least none that I know of, where a string of what is this, 7 less thans, 7 greater thans, and 7 equal signs is valid syntax. So you can see it's flagged it that we've got a syntax error here. That's something that Git does to act as a kind of an additional little eye catcher for you to let you know there's a problem in this section of the code. But what this is telling us is that the change that we made to our branch, the refactor modify comment branch, that's known as the current change. It's saying, here's what it looks like on line 4. But the contents of the development branch up in GitHub, that's the incoming change. This is what it looks like on line 6. So to resolve the merge conflict, we have to basically decide which one of these is correct. Or is it a case where they're both kind of correct and we have to merge them? So one of the things I could do is if I decided that line 4 is the correct line, I could manually delete line 3 and then line 5 through 7. But Visual Studio Code and WebStorm does this, and other IDEs as well. They make it easier. They have this button that they put up. If I click Accept Current Change, watch what happens. It did it for me. Okay. So now, if I were in a real project rather than a presentation, I would unit test this code to make sure it works. You know, I have made a change. But in this case, I'm going to save this. And actually, I need to look and see if there's any other. Yeah, there's no other merge conflicts. So now I'm going to do a git status. And we can see that we have a modified file. So I'll do a git add. I'm going to do a git status again. Yep. So then I'm going to do a git commit. And now I'm going to push this up to GitHub. There we go. So now let's go back to GitHub and see what this looks like. So one of the great things about GitHub, I think, is I didn't have to delete the PR. You notice that what I did is the PR was detected in the creation of the pull request, but I went down to my local PC to to resolve the conflict. And when I pushed that branch back up with the fix, GitHub automatically detected it. So it's saying now that, hey, there's no conflicts. We can merge this pull request. And before I do that, I want to look at this commit. I just want to look at the code and make sure everything looks okay. And in fact, we can see it's C to Fahrenheit, which is what we expect. So I can hit merge pull request, confirm it, and that is now merged. If I go back to pull request tab, there's no open pull requests. Another nice thing about GitHub is that you see this 91 closed. Over the course of the last 4 years, we've done 91 PRs to this repo, and it's got the history of every one. So this goes back to what we were talking about earlier about atomic commits and atomic changes. If there's a problem that happened in this commit, I can go back to this PR. I can go back to the prior PR and compare the code when I know it was working to see, okay, what did we change? That's a good place to start for troubleshooting. And let's go to the code real quick, and let's just kind of verify that everything looks okay. And it does. So up to this point, where we're at is we went through some of the 8 basic Git commands. We talked about the workflow that Git has on your local PC and the fact that, what you think of as being the repo is actually a working directory. That's this part. The actual repo sits in this hidden .git file. This one right here. And we talked about, how to get changes from the working directory to the staging area and then finally to commit them. We did a quick overview of GitHub, and we showed how to do a PR and how to resolve a merge conflict. So any questions up to this point? All right. So let's skip ahead here. I will put a copy of this deck out in the Town Hall chat channel after this session, so you'll have it. Again, for a PR, a pull request is really a request that you're making to one or more other people on your team to review your changes before they get merged into the main code base. And it is most definitely a best practice. I wouldn't violate this. Your team should decide, how are you going to do the reviews? This is kind of a short flow chart of what that review process looks like. But your team should decide, when someone on the team creates a PR, who needs to review it? Should you just randomly assign some other teammate? Should all teammates review every PR? Should you rotate the responsibility? There are, while there may not be a right and a wrong answer, there's definitely some answers that are cumbersome. Having all teammates review a PR is going to slow the process down because, you have to, let's say there's 10 people on your team. Well, if 9 people have to review it, that's probably not going to take hours. That's probably going to take days to get everyone coordinated. Another consideration is if you allow any teammate, you just randomly pick. The problem with that is that we tend to pick our friends. So, I would, if I'm creating PRs in my team and Doris is on my team, I run that risk of always choosing Doris. And because we're friends, Doris would be more lenient on me than she might on another team member. She might not do it as complete a review uh, because we're friends. So it's good to talk about. You don't have to drag out the discussion, but it's good to discuss what's your strategy for who reviews PRs. And what a lot of teams do and avoid, and even in out in the real world, they choose the person who is most familiar with the code other than themselves, uh, or they rotate it, or some combination thereof. So I am at the end. We got done a lot faster today than what we have in prior sessions. Uh, are there any questions about this or anything else? I caught the whole discussion about RTFM too. That's pretty funny.
Just a quick other point, if you and Doris are friends and you're constantly hitting on her for reviews, she might get a little tired of that. Maybe it could start harming your friendship.
Well, that's true. That's true. Uh, the other danger you run is if you always choose the same person, even if they're just generally, more lenient, if they're doing all the reviews, they're probably not going to do as thorough a review if they're doing, one or two a day. So, I really, in a voyage, to be honest, I like this solution of rotating the responsibility uh, in each sprint, or rotating it where everyone has a day. That's not a bad solution either. The other thing to focus on too on a PR review, think of it as a way to learn, both for the reviewer and the person who's creating the change. So while you don't want to, again, you don't want to drag the review out over weeks and weeks and weeks, uh, you should be asking not just questions like, does the code work? You should be looking at how does it work? And does it work as well as it should? And is there any way it could be optimized or improved either for performance or maintenance? Is there any technical debt in this particular implementation? Uh, you really need to look a lot deeper than just does it work or not. There's a lot of code out there, a lot of applications. Yeah, they work, but that doesn't mean that they work well. Yeah, tech debt is that's an ugly one. I've lived through that. I'm living through it right now in a couple of my bots that I have. So yeah, I'm just pausing. I see people are typing, and I want to make sure that if you've got any questions about this or anything, that we help get them answered. Yeah, very true, Andres. Yeah, your comments should be professional. Uh, you're not code reviews are not shouldn't be viewed as a zero sum game. Where there's one winner and one loser. I've seen a lot of situations, as I'm sure many of you have, where someone might do a code review or even in a presentation or just working side by side, someone might feel like, oh, I have to always be the winner. And I'm not justifying my position unless I could degrade someone else's work. Uh, that's not the way it should work. We're all going to, as a team, we're either going to get there together or none of us are going to get there. There is no partial success. And it's just so much more fun to work in a team that's cooperative and where, you're looking out for each other and you're trying to help each other. That just makes it more fun. The worst team I ever worked on, I had a CIO that wanted a team of all superstars. And I still to this day don't know why I was on it, but the egos were just unmanageable. Uh, Meetings drug out for hours because they became battles over, the members of the team reviewing just routine decisions as, oh, I have to be a winner. If my idea is not accepted, I lose. Um, it was just a dreadful, dreadful experience. Uh, the best teams I've worked on were multinational, multicultural teams where people were at different levels. There were entry level and senior level, um, and wasn't a lot of ego. Uh, those were the best teams I've ever worked on. Yeah, very good, Zephyr. Focus on situations, not individuals. Yeah. Yeah, now that's a good idea too, to have two reviewers. Another variation of that I've seen that I think works well too, pardon me, is where the creator of the change and the reviewer treat it like a pair programming session. So they go through the change together. Um, that can have some real benefits, and it tends to be faster than just, oh, I'm gonna create a PR and you're gonna review it, and then when you're done, I'll look at the comments and that kind of that back and forth. Doing it in real time has some advantages. The other thing to think about too is that those review comments, they become part of the history in GitHub. So they can be really valuable as troubleshooting tips as well, or troubleshooting uh, data. So yeah, any other questions, anything at all? Otherwise, we'll close this session out. I think on Saturday we have an open topic session. We typically do one of those at the beginning of every voyage where we don't have a set topic. It's just whatever issues you may be having, questions, anything at all, problems. That will be at 9 a.m. Chicago time on Saturday morning. And one bit of info in the Chingu Discord server at the top of the channel list. There's an events channel. Unfortunately, you could only see it from the browser or from a PC client software. You can't see it from a mobile device. But we post all of our meetings out there. Let's see. Uh, oh, you can see it in. You know what? Maybe it's just some mobile devices because I'm not able to see it on mine. Oh, thank you, Luisa. So I think it's time to wrap this one up. Um, Again, I hope everyone is having a good start to the voyage, um, and we have some exciting things coming up in the next couple of months. Um, but thank you all. Thanks for your comments and your suggestions and your feedback. Really appreciate that. And we'll talk to you all later. Bye bye.